demonstration of a virtual surgical planning session for a tumor in the distal humerus. So we've got a right arm and right distal humerus with a tumor on it. First thing we're going to do is hide the other bones. So select the other bones, right click and hide them. For this surgical plan, we're going to assume that the margin for this tumor is 1 centimeter. So likely that it's going to cut out a fairly large amount of this bone. So what we'll do first is make the bone medium transparency so we can see the depth of the tumor. We'll duplicate the tumor by right-clicking and duplicate. And we're going to make a hollow version of the tumor by, say, 1 centimeter by the amount of the margin. So we do that with the design hollow and hollow outside. This is in millimeters, so you're 10 millimeters. And if we remove original, that'll mean it'll be basically a solid, one solid piece. It won't actually be hollow in the center. So if we do that to the hollowed tumor, you'll see exactly where that margin kind of intersects the rest of the bone. And we'll plan our resection planes based off of that sort of enlarged tumor. All right. So that looks like it's going to basically take out the whole segment of the humerus here. So let's do a slightly smaller margin in this case, just for demonstration. So let's see, it's a 5 millimeter margin. So duplicate. All right, here's our hollow tumor. And the objective here is we're going to place some cutting planes. First kind of factor is where's our surgical approach coming from? So are we coming from the posterior side or coming from the lateral side? The typical lateral approach might be useful here. So we're going to place that in a lateral perspective, and the goal will probably be to minimize the amount of healthy tissue that's resected here. So we're going to try and keep as much of this healthy bone as possible. And we're going to place some cutting planes in there with our analytical and datum plane. And we'll use this kind of method, this through 2 points perpendicular view. Click point 1, start right here, and we're going to make a cut of it. Probably try to just make 3 straight cuts here. So we're going to end this point so we can place another point kind of over here or right here to make the third cut, kind of encase this forward volume. So once we do point 1 on the edge here and point 2 up here, click apply. And then since this is point 2, we can change the point 1 over to somewhere over here, which will ensure that we're outside the margin. And click apply again. And then we can click back to point 2 over here and try to do a third line that'll stay outside this margin. and make it really simple, just 3 straight cuts. All right, and once we have those, escape, and these will be our cut planes. Now we can swing them around here and we can see their trajectory on that, on the bone. The next thing we're going to do is hide that. And we're going to take this humerus and we're going to duplicate this one. And we're going to hollow this humerus by 0.5 millimeter, which will give us a small clearance between the bone and the guide. We'll do outside again. We'll also remove the original. Just slightly larger, smallest detail here, just so it's a little bit faster for us. Right, so it did that. So this is hollow by 0.5 millimeter. Hide the original. All right, since our guide's going to go on the surface, we're going to use the shortcut N on the keyboard for the marking tool. It can also be under here, and it's called wave. It's the wave brush. It gives us a little marking brush, and we're going to choose, make sure expert mode is on down here. So if that's off, you want to click this yellow button, which gives you a couple more options in these parameters. So for selection, click on the part surface and brush diameter 3 or 5, whatever. And we're going to paint around this section here. This is kind of the surface of the bone that we're going to put the guide on, and we're going to be able to cut outside the bone. If we just drag this, it'll paint on the surface that's visible to us and not through the whole bone. If we mark outside, if we hold control, you'll see the plus turns to a minus on the cursor. And if we paint that, lets us erase some things. And the next thing we're going to do is smooth the marking border with this button here. And that will give us a nice, small, smooth border here. We hit escape, click on the surface, and we can select that surface. What we're going to do is right click that and do separate, copy to part, and create new. That creates a new surface by itself in a new part. We're going to make this a guide body by doing design, hollow, and choosing both as the hollow type and 5 millimeters, and making sure you uncheck remove original and apply that. That's going to make a guide body. So just label that guide body. And now we're going to cut that guide body with these cutting planes to refine that a little bit more. So click the guide body, do Control X on the keyboard, and click your cutting entity and click one of these planes. You can create new parts, and we're going to leave the original there. So click apply, hide your original guide body, and find the small piece that's been cut off and delete that one. So just hit delete on the keyboard and then OK. Then we're going to use this guide body, and we're going to click cutting entity. We're going to click the middle plane here, and this time we'll click remove original as well. Then click apply, and then find the smaller piece again. Delete again. And repeat one more time with cutting entity as the final plane. And click apply and find the small piece. And I'm telling the small piece because of this white bounding box that surrounds it. So with that, now we've got this this guide body that should fit onto the tumor. Oh, sorry, fit onto the distal humerus and allow us to cut on these three planes. We can hold shift, select all these and group them. Call them guide body, guide parts. Then we can hide that. And as we accumulate geometries and things that we don't need to see anymore, we can drag it into that folder. We can see that the guide itself might interfere with the tumor on this. We'll worry about that at the end. We're going to create some geometry for fixation holes here. So I want to make sure that when I put a K-wire in the corner of this guide, it's not going to intersect with the hollow tumor. So make your guide transparent and show the tumor. In this case, it is pretty close. We're going to make some cylinders for K-wires. So we'll click on this axis, try to normalize the direction. The length that is maybe 15 and the radius as 75. We're going to have to click apply and hit the shortcut G to move this cylinder into the guide body. So I'm going to click rotate and use this green circle to get it kind of straight aligned with the guide. And then use translate with our screen to sink it down into the guide. Basically, what we're looking for here is we want to be sure that when the surgeon cuts along this hard edge, that they're not going to hit the wire that they use to fix the guide. So basically, don't want it to go outside of these boundaries here. So making it parallel is okay. And as you do this, you may have trouble with the viewing. So if you hit the middle mouse button and drag it, that's panning across the screen. If you right click and drag, that'll rotate. And if your mouse is toward the edges of the screen and you right click and rotate, it'll do a clockwise, counterclockwise rotation. So that's how we're moving around. This green circle in rotation is just whichever way you're looking, it'll move clockwise, counterclockwise. And these different color circles will rotate it in that axis of rotation. Okay, so here we're going to duplicate the cylinder with Control D, and then we'll use a translate tool and move it with the screen, move it to the next position. And maybe one more kind of at an angle this way. So duplicate again and translate this way. And then use rotation, and we'll make this sort of normal to the surface here of the bone. So it's kind of going straight in. Make sure that doesn't intersect that cut here. So that cut is going to be coming straight down like this. So There we go. So these three analytical cylinders, I'm going to duplicate all of those. And for each of these, I'm going to make the radius 0.25, which will give the cylinders basically the extra material on the outside. And for each of these three cylinders, I'm going to translate them to the second tab here, translate the first I will highlight all of these cylinders and use the design and convert analytical to mesh here and click apply. Then I'm going to drag all these cylinders that I've highlighted right into the guide parts folder. Then the most important part here is that your cylinders are going into the bone surface. We're basically going to subtract the bone at the end from this guide, and we want to make sure that that middle cylinder that we've got, the smaller one, is going to be a hole, and that goes all the way through the guide body itself, so a minimum of 5 millimeters depth here. So basically what we want to do is we're going to grab each of these basically housings that are going to be around the holes and move them with their inertia axis, translate them down closer to the surface of the guide, but sticking out a little bit. Yeah. So we just work on the next one. Hit escape, G on the next one, and translate that down, and then one more, and translate that down. All right. Next thing we're going to do is now we're going to Boolean Union basically all the positive features of this guide. So we've got the guide body, control, these last three cylinders, and hit Control B. That'll create a new part. Check these. This will be the final guide. And I put patient name here. Here's the guide. Nice guide. All right, and then I'm going to hit Alt B while this guide is selected, which will do Boolean subtraction. Otherwise, in the design tab, you have your Boolean operations here that you can select. And basically, we're going to take whatever's in the top and subtract whatever's in the bottom. So we're going to subtract these three cylinders. We can just click on them directly, or you can click on them in the part list here. Those will be the first three. We're also going to subtract the hollowed humerus bone. So that'll be on the bottom of the list here, and then click apply. And then you can drag all of these cylinders into the guide parts folder, and you'll be able to see that it's gone through. This guide body should also go into the guide parts folder, and you're going to make sure that it's not intercepting the bone anywhere. We've got a little extra piece down here that's not connected, so we're going to use F7 on the keyboard, and then we should be able to delete that separated piece. It looks like the tumor may be hiding the connected pieces of this. So here's a good time for us to trim out the portion of this guide that's going to intersect this physical obstruction of the tumor here. So we're going to show you the trimming tool. So Alt T, or under Finish, Trim gives you this tool. And we're going to click on the guide, make sure that we're trimming the guide. Remove the inside. We could make this transparent if we wanted to see, where's the rest of the tumor. And I want this guide to fit really, really uniquely on the humerus bone. So we're just gonna make sure there's enough contact area between the guide and the bone for it to be fit uniquely. So having it kind of hook around here is good. And we give it this fillet tool on to make nice, smoother edges to it. Put that number in about 50. And we'll just click, and then just surround this part basically. And you'll see the preview of how that guide looks. And you could drag points out if you want. Making sure you give enough area for that saw to kind of follow the flat side of the guide. And I'll click apply. So maybe it's too close to the tumor here, so hit Control Z and try one more time. Maybe I'll come up and so let's try that. Okay, I think that looks pretty good. All right, right click and unlock all. You can change the color of the guide by just clicking on it and change the part color. We're going to print it on an orange color material. Doesn't turn all orange, then we can go into here, click surface list, and click this top button. Right. The next thing we're going to do is put a label on this thing. So take a quick label right here, and we're going to put a little unique identifier. So whatever your number is that identifies the guide, you can put it there. You can set the size of the numbers here. And I like to put a bold font so that if this is 3D printed, then it's easy to clean. There's no really narrow holes for the resin to get trapped in if you're using resin, or powder to get trapped in if you're using powder. You don't need to create a new part. And if you hold Control, that'll be an engraving. So you see the A on that little icon gets sunk in, and then left click, and then that'll create your indentation of your label at whatever depth you set here. You could do a 0.5 millimeter or a millimeter. And the next thing we're going to do is create some fiducial markers. So these will be 3 points at 1 millimeter diameter each, and they'll help us ensure dimensional accuracy on the model after it's printed. So I just click center point over here, click on the model, do that 2 more times. I'm going to take the guide, Alt V, subtract all of these, drag these into guide parts. And then we're going to make some measurements between the nearest edges of each set of indentations. So click once on each nearest edge, and then the third click will just be anywhere to place the label. All right, and then you take a screenshot of this, save it for reference for after the part's printed. Okay, and then we might put a label which tells us, what's the direction of each of these things. So we might have a superior direction and an inferior direction. And so this distal end is inferior and this end is superior. So same way we made the other one, we can put these labels which help us indicate which direction. We might also put these carets which tell us, which sides are going to be cut. But a little indicator that says cut. If your label doesn't change, just hit enter. That a few times here. right, that's pretty much it. So there's our guide. It's got unique labels, it's got fiducial marks, it's got anatomic references, it's got indications of where to make cuts, and it's got screw holes and housings for fixation, which are kind of avoiding the tumor section. And it's got hard edges on this guide, although in some cases you may use slots. But that is basically how you do a surgical planning session and a little bit of guide design at the same time. After all of this, I'm going to produce a summary of all of this for the surgeon, which will help guide them how to use it. So you likely will start with screenshots. You can hide this hollowed humerus and just use the original. We do screenshots. You might do opaque and transparent from a couple different angles, which help them see what is the depth of the tumor at different perspectives. Then we might show our planned resection of the. Think about how the patient's going to be on the surgical table. The arm is out and looking at the back side of the arm like this. We're going to show first the resection planes. We might show the hollow tumor and how it sits inside our planned resection planes. Then we might show the guide, and that shows that the guide also follow these resection planes. And we might make the guide opaque and helps us view the labels that are written on the guide. We might do a couple of perspectives of the guide to show how it sits on the bone and where it sits on the bone, so we can have a little bit perspective there. And we probably do that with the original tumor. In the operating room, then they're going to see what does the tumor really look like, and how does the guide sit in relation to that. All right, I hope you enjoyed the video of demoing a virtual surgical planning session, designing a guide based off of the resection planes, and what kind of screenshots you might use in a case summary to describe how the guide is going to be used in the operating room. All right, thanks for joining.